Today we are going to start up with alkyl halides. We ended up with the alkene so far. So alkyl
Yes.
halides. So first of all, what is uh, what is actually an alkyl halide? Is derivative of alkene in which one hydrogen of alkane is replaced with a halide. Now halide includes chlorine, bromine, iodine. We don't usually consider astatine as an halogen, but just for the sake of all halogens, I'm writing. Now,
Okay.
types of alkyl halides. There can be different types of alkyl halides based on the attachment of the halide group. So let's say if that is a carbon and that's the X, carbon X and carbon X. So we may have this carbon attached to one more carbon and rest hydrogen. So that becomes a primary alkyl halide. Few authors they write it as 1 degree alkyl halide. If we have a carbon
Okay.
and halogen that is attached to such a carbon that is further connected to two different carbons and one hydrogen, so it becomes a secondary alkyl halide or 2 degree alkyl halide. Similarly, if halogen is attached to such a carbon which is further attached to three different carbons, it becomes a tertiary
Tertiary.
3 degree alkyl. So that's the classification. Then, if we talk about preparation of alkyl halides, are they prepared first by free radical substitution of alkanes? We did that part, free radical substitution of alkanes.
Yes.
So we can skip that part as like, for example, we have methane. It ends up with what? Chloromethane and HCl in UV light. So that's basically that's an alkyl halide. Similarly, addition of halogens to alkenes. We did that earlier too. So if we have an alkene and we supply it with maybe chlorine and CCl4 is needed, so what happens is we have an alkyl halide. So this is what you've done.
Okay.
However, the new technique is from alcohols. So from alcohols, we can have a reaction with ECl5 or ECl3 or SOCl2. ECl3 requires heating or simple phosphorus or iodine or HBr. So all of these reactions will eventually give us an alkyl halide and water.
Okay.
So if we are reacting it with PCl5, so obviously this could be an alkyl chloride. PCl3 alkyl chloride, SOCl2 is alkyl chloride. Then if we talk about iodine, so alkyl iodide, and if we talk about bromines, then alkyl bromide. This phosphorus here is only there to eliminate this OH.
Okay.
So that's how we discuss about the preparation of alkyl halides. That was what an alkyl halide is. That's how we prepare it. Now, the chemical reactions. That's the most different and most important part of alkyl halides. The chemical reactions, as we have talked about alkanes and alkenes. So alkanes were identified by what? Alkanes were identified by what type of reaction?
Sorry?
Alkanes were identified by what type of reaction?
Addition.
No.
Sorry, tracking.
Alkanes were identified by free radical substitution reaction. Alkenes were
अच्छा
identified by addition reaction. Okay. So now alkyl halides are identified by nucleophilic substitution reaction. You remember nucleophile?
जी
So nucleophile was what?
और
Any ideas? So it's a species which is electron rich, which can donate an electron pair. Electrophile was something that was electron deficient, right? So it's not necessarily negative. It can be negative, it can be positive. So it's nucleophilic substitution that happens with something electron rich. Now, the problem with the alkyl halides are they are very, slow reactive. They have very slow reactivity, slow reaction. Also, they are volatile. So if we want a reaction of an alkyl halide with anything, so it's either, too much time consuming. That's, one part of the problem, too much time consuming. And the other part is if, we want to activate this alkyl halide by heating it, so then it, readily evaporates. So that's the challenge.
okay
Evaporative. It's highly volatile. So now we are in a problem that what to do. So to overcome this, what we do is basically we do reflux heating. That is heating with a mechanism called condensation. Now what that is. So let's say if I say that I'm having a flask, and that flask contains some fluid that is something A and B, and let's say A is an alkyl halide and B is something else. If we heat this up, we know that alkyl halide would evaporate, right? So what we do, we just extend up this neck, and then there is a metallic tube encircled here. Water, is rolled into that tube. It doesn't pass through this. It's just encircling this neck. So what happens is
okay
we pour some cold water in, and it turns hot here, so hot water. So what's the benefit of doing this? Any suggestions?
will it make the reaction fast?
So it will, keep this region a bit colder, right?
Okay
Why is that so? Because we are bringing cold water. So if anything that's, evaporative that has been reached here would ultimately condense and fall back.
okay
We get this?
yes
So we can complete this reaction with, with repeatedly doing this. But the benefit is that gas, that volatile substance, doesn't leave this container out. It stays there. Water is cooling in, and then water is changing heat, and then it is absorbing energy. And this kind of mechanism is known as heating under reflux. We get
okay yes
okay. So these reactions, which were supposed to be nucleophilic substitution reactions, are generally titled as SN reactions, named as nucleophilic substitution reactions. Nucleophilic substitution. Okay. And in this category of reactions, we have two basic types, SN1 and SN2 reaction. What is an SN1 reaction and what is an SN2 reaction? Before going to that, we'll differentiate among. So let's say this is SN1 reactions and that's SN2 reactions. So SN1 reactions would be present or would be shown by tertiary alkyl halides
Okay.
SN2 reaction would be shown by primary alkyl halides. Then SN1 basically proceeds in two steps. So we have, as we are going to discuss the mechanism, so you'll see that there are two steps, step 1 and step 2 in SN1 reaction. However, in SN2 reaction, it's a single step reaction. Then since it is a two-step reaction, so there is intermediate product forming, intermediate forms, and that's a carbonium ion. So what is a carbonium ion? Carbon with a positive charge. So since it is a single step reaction, there is no intermediate product, and that's only a transitionary state, and no intermediate product is found. And then rate of the reaction essentially depends on only one thing, that's alkyl halide. That means no matter how much nucleophile you have, it only would be balanced out by alkyl halide. But here, rate of the reaction depends on two things, alkyl halide and nucleophile. So that is why we name this as bimolecular. And this is basically molecular.
Okay.
Yeah. So now we'll start up with SN1 reaction. So what's an SN1 reaction? So first thing is it has to be a tertiary alkyl halide. So let's say, we have an alkyl halide, let's say, something like this. So do you agree that this is a tertiary alkyl halide?
Sorry?
Is this a tertiary alkyl halide?
Yes.
And how do you know that?
Because it has 3 carbons in it.
That's great. So if there is an attack on nucleophilic substitution happening, so let's apply this with NaOH. So OH is a very good nucleophile, aqueous, and then we have to heat it under reflux. So what happens? Initially, when you heat it, this happens. So you can see that this chlorine has left the carbon. So that's the step 1.
Okay.
So that's the intermediate, and that's the carbonium ion.
Right.
Then the step 2 would be what? The attack of the nucleophile. So the nucleophile, if we are using NaOH, would be obviously OH. So it would, attack on this. Then what should happen? So this gets attached here. So it transforms to what? An alcohol. And this is a very fast reaction. It's a very slow process. So that is why this is also a rate determining step. Because whenever we are calculating, rate of a chemical reaction, we always calculate rate based on a slow step. So out of these two steps, step 1 is the slowest, and step 2 is the fastest. So step 1 is the rate determining step. So if I write the rate equation here, so it would only be dependent on the concentration of alkyl halide, because the slow step only involves, alkyl halide. There is no nucleophile here.
Okay.
Is this?
Yes.
Is this clear?
Yes, sir.
That's great. So now, if we talk about SN2 reactions, now you can, link that to it. That SN2 reactions would be basically a single step reaction, and that happens to be from a primary alkyl halide. So let's say we have a primary alkyl halide, a carbon that is only connected to one more carbon. And then we have the same, maybe the nucleophilic reagent, heat under a flux. So what happens? It passes through a transition state, not the intermediate state. That's very important here. The transition state is we are going to have an attack of OH here, and we are going to have the Cl removed simultaneously. So this kind of arrangement happens. You see, you show it with a dashed line that chlorine is going away and alkyl group stays where it is, hydrogen stays where it is. So essentially, it's the same thing, but with a different orientation.
Right.
So there is only, change in orientation, or you can say change in the bonding molecular structure. So what happens? This has to eventually win, right? And this has to lose. So it is a transition state. It is a very, very temporary state. So we cannot identify what actually is this product, but it could ultimately lead to what? It could ultimately lead to a very, fast process. And that fast process, basically, it's, no, let's not write fast because it's a single step case that can create an. So eventually, we'll have this CH3COH and H and H with Cl. So essentially, OH has substituted chlorine. Do you get this part?
Yes.
So that's an alcohol, but that's a single step reaction. So if I want to write the rate equation, so I am, bound to write my alkyl halide as well as my nucleophile. Why? Because they are present in the entirety of the reaction. They're both present. However, in the SN1 part, there was only one reagent that was an alkyl halide. You get this?
Yes.
So that is basically SN1 and SN2 reaction. Of what?
Sir, I have a question.
Yeah.
For the rate equation, how will we identify the nucleophile and the aldehyde?
How would you identify the nucleophile and
The aldehyde.
alkyl halide?
Yeah.
So nucleophile would be this,
Hmm.
and whatever halide is there, you can replace under the X.
Okay.
So here I can write it would be RCl. And OH.
Acha, that's it. Okay.
Do you get this?
Yes.
Okay. Now, if we talk about the energy profile diagram, that's what we used to draw in O levels. Profile diagram. So let's draw it for an SN2 reaction. So that's an alkyl halide. And then it reaches out to some transition state, and then finally two products. That's an alcohol. So that very much means that this reaction should be exo or endo.
Exit.
That's great. So this should be an exothermic reaction because product is at a lower energy level than the reactant, right? That's the reactant and that's the product. So product is below reactant, so product has less energy. That makes sense.
Right.
Okay. What about if I talk about an SN1 reaction? So in an SN1 reaction, we have to recall that it was a two-step reaction. So first step, that's an alkyl halide. It reaches out to some transitionary state, and then it forms an intermediate. That's the carboniamide. So that's the intermediate state. So that's endo because it requires us to give some energy. Energy in progress.
Right.
Progress. And then what happens next? This further reaches to another transition state, then it falls down.
Okay.
Let's extend this. So that's ROH. So that was the transition state. That's the final reaction. Ultimately,
Okay.
this is again an exothermic. So do you get this?
Yes.
If you kind of get this, it becomes very easy for for us to go through alcohols because alcohols they show similar type of reaction. So
Okay.
next is an amine formation that is basically from again alkyl halides. How is amine formed? So we have an alkyl halide we reacted with ammonia. So we use alcohol here. So what happens is CH3, CH2, NH2 with HCl. Sorry, HX. So what has happened? This has happened. There is hydrogen here. So if I'm having CH3Cl with an H3, so what should I write? I would write CH3, NH2, and HCl. To be sahi karna hai. That should not be this. That should be RNH2. Make sense?
Yes.
So that's a chloromethane, and that's a amino methane. You get this?
Yes.
Hello?
Yes, sir.
Do you get this? I think you're sleepy.
Yes. No, I said yes.
That's a nitrile formation then. So what's a nitrile group? It's a CN group. So if we have an alkyl halide, we reacted with either potassium cyanide or sodium cyanide. In alcohol, so what happens is we can have RCN with KX or NX. We get this?
Oh, yes.
So if we have CH3, CH2Pr here, and we use KCN and alcohol here, so what we have here is CH3, CH2, CN with ABr.
Yes.
So the same reaction is true for alcohol, potassium too. We get this?
Yes.
So that's a bromoethane. That's a potassium cyanide. And that's what ethyl nitrile. That's not the IUPAC name, but that's not part of this list. So let's not, discuss that. Let's keep it at ethyl nitrile.
Okay.
So that ends alkyl halide.
All right.
Yeah. So is there any question?
No.
Okay. Then we can end this and you can go to your sleep.
Okay.
Allah Hafiz.
Hafiz.